Hey,
Hello.
hello,
Welcome. Hey,
welcome.
hey.
Hey.
Hello, everyone. Welcome to You Choose. We're in Chapter 3, Episode 3, and we're talking today about secrets management.
Secret
Se-
stuff.
Shh.
When
We're
we
going to
say we
talk
talk
about
about
it.
secrets, we shouldn't talk about it. So we can just end here.
There are no secrets. The end. Victor, I'm so excited for today's show. We have
Yeah?
some, we have some super fun and wonderful guests backstage. I mean, we always do, but my sides hurt from laughing during the pre-show, so that's that's a good sign. But let's talk about last week first. So last week we talked about runtime policy. We covered two technologies. We covered Falco and CubeArmor. And we should recap those two technologies very quickly. So go for it. Each
Yeah.
technology in one sentence.
So those are very different. Falco is about
Uh-huh.
uh, having understanding of what's going on for good or bad in your cluster, right? Detecting stuff, being alerted on things.
Yeah. When I think of Falco, I think of alerting. Like the word alerting is.
Yes, exactly. That would be probably the closest thing. Just typically people associate alerting with metrics and observability of other kind. This is alerting around processes mostly that are being executed and probably shouldn't.
Right. So it's looking at kernel level stuff. It's not looking at application level
Exactly.
stuff.
Somebody's in your system and is ordering pizzas in your name. You
That
should
doesn't
do
seem
something
so
about
bad.
it.
Just alert the delivery is about to come.
Exactly. But you need to know about it, right?
You should be hungry. You don't want to eat beforehand. And then with Falco, you can take action on alerts and stuff too, right?
Yes. But the important
That's
thing is
mostly.
that I still see it mostly as alerting, right? Because you can take actions, but after the things happen, right? Not before things happen. And that's important part, right? You will find out that something is happening and you will do something in one way or another. And that's where CubeArmor jumps in. CubeArmor is capable of preventing things from happening, right? So it can detect that somebody is about to execute some process, and that process shouldn't be executed based on the rules you set, and CubeArmor can prevent that from being executed in the first place.
That's pretty awesome. And then we also talked about some reasons why you might want both. Like you might want.
Yeah, if I go, you said one sentence, right? If I limit it further to one word, Falco would be detection or
Okay.
observability,
Uh-huh.
and CubeArmor would be prevention, right?
Okay.
And they work very well together, actually.
Excellent.
Because
But
it would be very hard for you to set the rules what should not happen if you don't know what is happening.
that's very true. The monitoring is a very important part of any policy making, whether or not we're at a kernel level. Yeah. So these two technologies that work well together, let's pit them against each other and force one to be chosen. What did the people choose?
Before we show that was
Okay.
very unjust voting because they're really not competing with each other, right? There is
Yeah.
really close to no overlap at all. And as we said a second ago, right? You're incentivized to use both. But one had to be chosen simply because we cannot demo two, in big part because I'm too lazy to do even one, so two would be over the board. So, yes. And the one that won this week, that would be CubeArmor. Was selected. Was chosen for me to demo it.
Not necessarily a winner. Yes.
Yes, exactly. And it was chosen for me to try to demo it, and based on previous history, probably failed to make it work, and then we figure it out during the session. We'll see.
Maybe you'll get it right the first time. I'm rooting for you.
Who knows? It's a
All right,
mystery.
Victor. I'm going to bring your screen up so you can add CubeArmor into the.
Okay. You see my screen, Whitney?
Yeah. So where are we starting from before you?
Yeah, so I have a cluster up and running. I installed KubeArmor. I did not define any policies. And I already have a couple of applications. I have stuff in that cluster running, right? And what I'm going to do first is show how, if I execute this command, right? What I'm going to do is that I'm going to go into a container of one of the containers that are already running in my cluster. And I'm going to execute ls to list the files in the root directory, right? Nothing special. What I want to show with this is to check with this, can I do something that is extraordinary? Even though ls probably is not that important, but can I do things that are outside of the functionality of whatever that container does, right? And a simple answer is yes, right?
Yeah.
That command was executed. I can see the list of files in the root. And I can now start poking around, find whatever I'm looking for. I'm simulating that I'm a malicious person over here, right? Now, what I'm going to do next is I'm going to annotate this namespace. I'm going to say, hey, the production namespace will have the annotation KubeArmor file posture is to block files, right? And I'm going to annotate my namespace with that. And then I'm going to show you one of the KubeArmor policies. So that's policies, there we go. And KubeArmor, here we are, Armor YAML, right? So this is one of the policies. What matters here is that whenever there is first of all, it is going to be applied on all the resources that have the label control plane schema hero, right? So whichever pod in my cluster has that label, this policy will be applied to. And then I'm going to say the directory in the root directory and recursive, meaning that basically it applies to anything in that container. And I'm going to allow only the process manager, right? So only that process is allowed to be executed in that cluster, right? In that pod. And bear in mind that before that I annotated and I said, by default, you block things, right? And then I'm going to allow manager to be executed. Nothing else should be executable in the containers of that pod, right? So now, since we already in previous episode chose Argo CD, among many other things, to do the synchronization, I'm going to copy that file to the infra directory. That's the directory that Argo CD is watching. And I'm going to add that file, and I'm going to commit something, and I'm going to push, right? Now it will take a couple of moments until, wrong one. There we go. Until Argo CD refreshes, figures out that there is a change and all this stuff. And now if I go back to my terminal, there we go, kubectl namespace production. I want to get or KubeArmor policies, right? And you can see that the policy that I showed is already in a cluster. Argo CD synchronized it. It's running for 20 minutes, right? Now, if I go back to the previous command, the same one as before, which was production exec, right? So this is the command that lists all the files in the root of the container. And if I execute it again, nope.
Yeah.
Right? So this is that prevention, right? It's not that it detected and notified me, none of those things, right? It detected that somebody's trying to execute that command ls, which is not the allowed command, and it was denied. And
No
that's about
pizzas
it.
ordered today.
No pizzas ordered today, nor the root files listed today.
Amazing. That's impressive. That's super cool. All right.
Yeah.
Good job, Victor. Good job, everyone, for choosing
Easy.
KubeArmor. I mean, it would have been great either way, but I enjoyed that very much.
I'm surprised at myself. Usually demos do not work without a hitch. So,
Yeah.
thank you, KubeArmor. It was not complicated.
Wow, it's like a little KubeArmor commercial. So now we're going to talk about secrets management. First of all, let's even say, what is secrets management? Why do we need a secrets management system design step?
That's very easy to explain. We need secrets management, so secrets stay secret.
What was the problem before? Why weren't they staying secret before?
Because the alternative would be if you send you something by email, that's not very secret anymore, right?
Uh-huh.
Or
so we
if
have
I
sensitive-
put it on Post-it, right? So, or push it to my Git repo, right? You want to keep the confidential information somewhere that is safe. That's step number one.
And
and
by
you
safe,
want-
we mean encrypted and hard to access, probably?
Exactly. That would
Okay.
be either, I mean, there are many ways how you can keep it safe. Two common ways is either by keeping it in some kind of secret storage or vault or whatever people call it, like AWS Secret Manager or this or that, or to encrypt it somehow and then keep it in a more public place like GitHub, right? So either you keep it in public, but it's encrypted and whomever gets hold on it cannot do much with it, or you keep it in a place that is inaccessible to anybody but selected few.
Okay.
Right? And when I say selected few, I mean, and we will see later, accessible to humans in certain ways or to processes in some other ways.
Yes. Those are two different consumers of secrets. And then also, one thing that is surprising to me, if I thought about this episode without knowing the technologies, I would have thought that we would be evaluating a bunch of different secret storage technologies, like vault technologies, but we're not. We're not evaluating any vault technologies today.
The answer is very, 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 very simple. Can you guess which one? What's the answer, Whitney?
There are none in the CNCF.
Exactly.
Okay. So the ones, the more prominent vaults out there, and a vault is what I understand to be a secret storage, but it also has to have API access. Those two things together make it a vault. Or they're key stores, which I don't really know what that is, but that's
Secret store, key store, there are some differences, but for the sake of argument, you can think of them in the same way, right? They're restricted, they're storage for your secrets that has restricted access, right? And generally there are, I would say, four that I'm about to name, probably called, excluding the cases where you keep them in public, like in Git, excluding those, the four that I'm going to name are probably like 90% of the market. That would be AWS Secret Manager, Google, Azure, and then HashiCorp Vault, right?
HashiCorp Vault.
Those four combined, as far as I know, are kind of vast, significant majority of places
And then-
people keep secrets.
One thing I learned as part of this, that it's likely for an organization to use one or many secret stores instead of having just one big one. Is that correct?
No, not really. I'm trying to.
So it is pretty.
I'm trying to figure out how to break it up to you without offending me.
I'll just be really quiet, like a single tear for the rest of
Yes,
that.
sometimes you would split them. So, for example, with Azure Secret Storage or whatever, the Azure Key Vault or whatever they're calling it, right? They
Right.
would recommend to have a separate one for each resource group, right? But it would be still
Or-
separate. It's more logical separation, right? It's still Azure Key Vault, right? Or
But if you have like
HashiCorp.
a multi-cloud kind of environment, wouldn't you like? Am I going to keep AWS
Yeah.
secrets in my Azure Vault?
Depends on the type of the secret, right? If it's a type of a secret that is specific to that cloud, you would probably keep it in the storage of that cloud, unless you're using HashiVault. Then if secrets are shared across different clouds you're using, then you would either replicate those secrets, I push it both to AWS and Azure and Google and wherever, or use one of them and then instruct all of those resources in different clouds to use that one.
Okay. So then when we're evaluating the technologies today, well, what's solved by a vault and what are we looking for? What are we hoping will get solved by the technologies we're looking at today? So like
So
storage
vault is-
and
Vault is
API
a
access.
storage. Exactly.
is secret rotation, like when secrets expire, is that a vault solved by
Yes,
a vault?
that would be solved by a vault, right? And then what we're solving today is how can we either, first of all, without a doubt, how can we retrieve those secrets from that storage?
Okay.
And potentially, how can we push secrets there in the first place, right? Because there is
That secret replication that you were just talking about would be something.
not only that, but especially lately, I've been working quite a lot on ways. Okay, so I'm generating secrets. Like, let's say I create a database, right? I have in Kubernetes, for example, right? I have authentication to that database stored in a secret, and then in Kubernetes secret now, not storage, right?
Okay.
And then I might need first to push that, to have a process that will detect it and push it to my storage, and then some other process somewhere else pull it from there. So it's not only getting it, but potentially pushing or storing somehow, right? Generating as well, depending on which of the four technology we talk about.
And some of them are probably going to deal with, one of the problems we need to solve today too is integrating secrets with Kubernetes, period, however you do that. Right?
Some with Kubernetes, some without. We'll see. We'll see how it goes. People have 5 minutes, so we'll see how far they will be able to get in 5 minutes. That's the major question here, right?
Yeah. So we're about ready to move into these 5-minute presentations from our illustrious, esteemed guests. But I would love to hear from chat too. Like, what are you looking for in your secret management solution? What's something that you feel like is lacking and needs improvement with a simple vault? And I do want to remind folks, like, I see there's a question right now in the chat. I think that's wonderful. We have a question and answer section at the end of the show, so we will dig in on your questions then. We are not ignoring them.
There is a strong chance that we will not be able to answer all your questions, so the sooner you ask questions, the bigger the chance that it will be answered.
That's true. We tend just to go in chronological order. Awesome. So are we ready to introduce our guests today?
Do we have to?
You can give all the 5-minute.
I got in a mood, kind of like here. I don't know. Okay, go for it. Party breaker.
All right. So first, we have our secrets operations guests. We have Marcus Noble coming on. Hello, Marcus. Tell us about yourself, please.
Hello. So as you said, I'm Marcus Noble. I'm a platform engineer working at Giant Swarm, where we are fairly heavy users of SOPS. So I'll be talking about that and hopefully swaying the votes in that direction.
Awesome. Thank you so much. And we'll see you soon for your presentation. Get ready. Like, do whatever exercises or deep breathing you need to do. All right. And then up next for External Secrets Operator, we have Gergely. Introduce yourself, please, Gergely.
Hello, my name is Gergely Breutigam, and I work at Weaveworks, and I'm here to persuade you to use external secrets instead.
Oh, I'm halfway persuaded already. All right, thank you. See you on the other side. And next
Wait, you were half persuaded by the first guest, half by the second, nothing left for the rest. No need to bring them in even.
Sorry, Anish. All my persuasion's been used up. Welcome. Tell us about yourself, please.
Hey, I'm Anish Ramshaker. I'm a software engineer at Microsoft based out of Seattle. I'm a maintainer for Secret Store CSI driver and an active member of Kubernetes SIGOT. And I'm here to talk about the CSI driver.
Awesome.
Can I give a suggestion personal to the project? Can you come up with an acronym that somebody can remember?
Sure.
SSCSID. I need to do a mental...
SSCSID, yeah.
See, I already made a mistake.
We already... it's encrypted. Once we decrypt it, it'll be something simpler. All right, we'll see you on the other side, Anish. And then last but not least, we have Saeed. Welcome, Saeed. Tell us about yourself, please.
Hello, everyone. I'm Said from CubeDemi.io, and I'm here to tell you and explain how Tele works to inject some secrets and credentials from.
Oh, you're telling too much. It's not presentation time yet.
Okay.
Yes.
Yeah.
Shall I start the timer? You really?
It's
I
counting
dare
against
you.
your time.
I dare you.
Say one more thing about Teller.
Okay. My talk is about Tele. We'll see you in the next space.
See. All right, and here we go. We're gonna do this thing. Marcus, your time starts when Victor says it starts. I'm gonna put your stuff on the screen, and here we go.
It starts now.
Cool. So I'm going to introduce you to SOPS today, which is a weird non-acronym for secrets operations. As you probably guess, SOPS is a tool for encrypting and decrypting secrets, secret data and stuff like that. It's a highly flexible and configurable binary tool, so it can work in like a lot of different use cases. It supports multiple file types, so JSON, YAML, etc., etc. And it also supports different encryption keys. So it's got support for AWS KMS, Azure Key Vault that we talked about earlier, and also like age keys and PGP. One of the things I like about SOPS is it works on encrypting individual values, not entire files. Because it's got this understanding of these different file types, so YAML and JSON, for example, it allows you to do partial encryption. So you can just encrypt the secret data within, for example, a secrets manifest YAML file, and the rest of it remains unencrypted, plain text, so it's still human readable. It's got some seamless integration with GitOps flows. So Flux has built-in support for SOPS, and Argo CD has support via KSOPS plugin that allows you to just seamlessly decrypt these in your cluster. It supports multiple decryption keys. So this is useful for if you have multiple groups of people that have their own key, they can all use that key to decrypt it. And it also allows for things like seamless key rotation. So you can associate both the old key and the new key at the same time while you're still changing everything over to the new key, and they will both work simultaneously. It also allows you then to use multiple of these backend encryptions. So somebody can use AWS KMS, another person could use an age key. It's got audit logging for to a Postgres database, so you can have a log of everybody that's encrypted and decrypted, what file, when, etc., etc. And one of the things I really do like about it, it doesn't require an operator to be running in your cluster because it fits into Flux, for example, or Argo CD. It's kind of seamless; it just works, and it doesn't enforce the use of a third-party service. So it doesn't require you to have AWS KMS, for example, unless you so choose to. So I'm going to show you a short demo. I'm not going to do this live because I'm a very clumsy typer, so you're going to have to go with what I have earlier. So just trust me that these commands work and are correct. So in my example, I'm going to use an age key. So we're not relying on any of the external services. What we want to do first is generate a private and public age key. So we'll use age keygen to generate the age key, and then from that we'll generate a public key. We can then create a secret that we're going to apply into our GitOps repo. So we've got a secret here, simple YAML manifest secret file, and it's got some data, the winner of this show, and we're going to save that to secret.yaml. And then we want to encrypt this using SOPS and our public key that we generated in the first one. So we'll call SOPS, we'll go encrypt, give it our age key. We'll tell it the input and output type. So this is how it understands that partial value-based encryption, so YAML. And we're going to give it an encrypted regex here, which tells it what parts we want to encrypt. So here it's data or string data. And then we're going to output that to string.enc.yaml, which will look something like this. I've trimmed this off at the side. This goes off way, way, way off to the side. There's a lot of data in here. But as you can see, it mostly still looks like a secret at the very top. So we've got the API version, we've got the kind, the metadata, all still human readable. Then when you start getting down to data, the key is still human readable, but the actual value is now encrypted. We have no idea what that is. And we've got this new SOPS property with a bunch of stuff under it that handles all the actual SOPS related configuration for this secret. If we want to decrypt it, get it back to what it was originally, we then use our private key that we generated earlier. Very similarly, we create an environment variable. SOPS age key is that key that we generated earlier. SOPS decrypt our encoded, our encrypted secret out to our decrypted one. And that decrypted file will then look exactly like what we had before. All that other stuff is gone and it's back to what our secret looks like. Now, on its own, this isn't hugely usable. Like I said, one of the things that's really nice is it fits in well into your GitOps flow. So I know that in previous episode, you ended up choosing Argo CD. I'm going to show you a Flux example just because it's simpler to show. So Flux customization that you have in your cluster will look something like this. General customization, name, metadata, your spec, the Git repository that you're associated with. And then you have this decryption property at the bottom. You tell it that the provider is SOPS, and you give it a reference to a secret within your cluster that has that public key, private key, sorry. Done.
Look how happy you made him. Good job, Marcus. Thank you so much.
It was so interesting that I completely missed the timer. But I got back to it.
You got some extra time in there because you did such a good job. Excellent. Thank you so much, Marcus. All right. Next up is Gergely. Gergely, I'm putting your screen on the screen.
Hello.
And
go.
your time starts.
Hang on. Give me a second.
Okay. But let it not repeat.
Make it bigger, please.
I need to bigger. Okay. Hang on a second. Is that better?
The only reason why I'm allowing you this is because you have a daughter and she might be distracting you. Otherwise, this is unacceptable.
Thank you. Sorry. Is this
yeah?
Is this reasonable? All right. 1, 2, 3,
Okay.
go. All right. So I'm going to talk about external secrets. And what I would like to tell for a high-level overview, it works with several providers that it implements. It's basically a controller that runs in your cluster. And then you have providers that you need to define. These providers are completely community-driven. So basically, if anyone wants a new provider for example, OnePassword or something like that, then the community will come together and implement it. And of course, we nurture the pull request through all this process, like getting it reviewed and up to speed. And then all of these providers are in a single controller. So basically, you have one binary which runs, but it runs 3 pods for injection and things like that. But it's only a single binary. And we have 3 main CRDs that you can use. That you can work with, which is the secret store that defines the store that you want to access. Then you have the external secrets that defines how to pull secrets from it, and push secrets, which defines how to push secrets to this provider that you implemented, for example, AWS Secret Manager. And then we have generators. So these generators can generate you ephemeral tokens that you do not need to save anywhere. So, for example, if you have an ECR or something, or some kind of registry that you need a temporary token to push things to, then you can use a generator to generate a token for it. So let's dive into a small demo. I have some setup here. You can see that I have all AWS secrets. I have a secret store, which I set up with some credentials. You can see that there's a role. This is very important. This role is pretty much tied down to, like you can see the role policy here, tied down to only access this kind of store. And this def here is very important as well, because you are only allowed to access secrets that start with that, for example. This can be fine-grained later on. Here you can see that I'm defining an external secret. It's rather fast, just bear with me. The remote key will be the one synced down into a secret. And then we have a failing one as well, which tries to pull a prod named secret. So you can see that I have a single secret in the secret manager, which starts with dev with the name. And this external secret, once I apply it to the cluster, will start to be reconciled. It pulls down the secret and puts it into a Kubernetes secret. And then you can do with that Kubernetes secret whatever you want. There's also integration with mounting and the legacy non-safe model of environment properties. So you can see that there's that secret was synced, and we have the secret value that we had, and we will try a failing one as well. And once you try a failing one, you will see that the status is, of course, a failed status. There's a secret, could not get the secret. And if you look at the events, bam, you see like all these errors that there's no identity based on that policy to access the secret that you wanted. This can be further fine-grained. You have role, you have ESO, you have all kinds of authentication that you can use and really narrow down the access of external secrets to make it more secure. So now we can, I listed the secrets, so now we will push some secrets, which is the other way around, of course. So if you see, I defined the push secret, and this is really powerful stuff. You can use templating in all of them. You can use templating in push secrets and external secrets and whatnot. And templating lets you modify the outcome or the income that you will get on the secret. So I have a Pokemon secret, which is like a single character like Pikachu, and I'm modifying it. That is really the best. So once we push the secret, we can see that the secret is now in the AWS Secret Manager. And we can see that there are 2 secrets. And now I'm going to like fetch the value, and the value should be the modified templated value, which is of course that once I change the RN for the secret ID, that Pikachu is really the best Pokemon. And these work 2 ways. So now if you reconcile it and delete the actual secret, then it will reconcile, and based on the deletion policy, it will actually delete the secret inside the AWS secret manager or whatever manager you happen to configure. And that's it for the demo.
You got the best of both worlds. You got to be gonged and you got barely finished with your, that was like a photo finish. That was exciting.
Exactly.
And
Last
what
second.
a reveal that Pikachu's the best Pokemon. Shocking development. Thank you so much. All right, Anish is next. Anish, welcome. Looking forward to your presentation. Let me get your screen on. Here you go.
Ready?
Okay. Yep.
Go.
Okay, so before we go to CSI driver motivation, so why are we talking about external secret storage when Kubernetes has a perfectly good one built in? First is Kubernetes secrets may not meet your data at encryption rest requirements. By default, data in etcd is base64 encoded, but it's not really encrypted unless you enable a KMS provider to enable encryption at rest. And then depending on your organization, you may have already standardized on a third-party secret solution and need to use that. Also, your external secret solution may be some sort of secret rotation story or integration that you're looking to leverage. And finally, if your organization has already invested in auditing and alerting on the third-party secret system, you may not want to duplicate the efforts for Kubernetes secrets. So what do you do? There are a couple of options, right? The first thing is you can obviously modify your application to fetch secrets from external API directly using SDKs. This may not be possible depending on your deployment because you may not have the code to edit, or it may be prohibitively expensive to implement these changes. And if you're targeting deployment against multiple secret providers, this effort would be duplicated. And then you might want to use Kubernetes secrets, perhaps with a controller. This is portable and won't require application changes, but you will lose out on some of the benefits because now you have a controller that has an identity and that has permissions to pull from any keyword. And then the other option is you could use a sidecar to fetch secrets, but we all know having a sidecar adds additional complexity. So that brings in the secret store CSI driver, which uses the CSI specification, and that's what we want to talk about. It was originally developed at DS Labs. The storage driver is now built and maintained as a Kubernetes SIGAUTH subproject. The driver allows Kubernetes to mount multiple secrets, keys, and certs that's stored in enterprise-grade secret stores into pods as volume. Once the volume is attached, the data in it is mounted into the container's temporary file system. And then in terms of the features, we have a familiar file system mount experience to compute workloads. It's also pluggable and supports multiple external secrets providers. And then it has support for rotation, which means if your secrets are rotated in the external store, it will automatically get rotated here. And then it also supports both Linux and Windows. And in terms of the supported providers that we have today, we have the big four that Victor talked about. In addition to this, we also have PRs open to add Keyless and Alibaba and other providers as supported providers. And this is just an overview of how the whole thing works. So a driver is installed as a daemon set onto each node in the cluster. And additionally, you have a daemon set for each provider that you want to use. So basically, when a pod is created through the Kubernetes API, it's scheduled onto a node. And then the kubeless process on the node looks at the pod spec and says there's a volume mount request. And then the kubelet issues an RPC call to the CSI driver to mount the volume. And then the CSI driver mounts the tempfs into the pod. The CSI driver then issues a request to whichever provider that you have configured. And then the provider talks to your external secret store to fetch the secrets. And once it's done, it basically sends the secret back to the CSI driver in the RPC response. And at this point, the driver mob adds the files into the mount, and then the pod's running successfully. And in terms of YAML, so here's an example pod spec. So this pod is mounting a volume at var secrets, and the volume is the CSI volume. So the driver in the CSI volume tells kubelet which driver to talk to. And then the volume also references a secret provider class called app secrets. So what is a secret provider class? It's basically a namespace Kubernetes custom resource that is used to provide driver configurations and provide specific parameters to the CSI driver. And here, basically, each provider have their own set of configurations, like set of secrets that you want, the identity that you want to use with the workload, and all of those, right? And then we also have another custom resource called the secret provider class pod status, which is also a namespace resource that is created by the driver. And basically, it is used to track the binding between a pod and a secret provider class. And basically, there are objects in there which tell you that what secrets are mounted into the pod and what versions of those currently exist, which are really useful when rotation happens and you see that the newer values are available. Now, that's my pitch. I think I rehearsed for 5 minutes and it was exactly 5 minutes.
Excellent. Thank you so much. That was fabulous. We'll see you again soon for the question and answer session. And last but not least, we have Saeed. Welcome.
Okay, all right.
Go.
Okay, yeah. Teller is an open source cloud native secret manager which helps you to inject your secrets to your application when you want to develop the application, test the application, or building your application in CI/CD pipelines. And the goal is when you leave with the secrets, it's better to do not leave them in your terminal or somewhere else. And the goal of Teller, in addition to providing a way to inject the secret, is to mix the secrets provider and allows you to use a couple of them at the same time to inject your secrets into your application. Here is a complete cheat sheet will be shared with you in the chat. And the good thing about the Teller is you can inject the secrets from etcd, AWS Param Store, Secrets Manager, Azure Key Vault, and a couple of other tools. And it can be integrated with Docker, Helm, Kubernetes, and a couple of other applications. So let me show you some use cases. With using the Teller, you can sync the secrets and credentials between development teams. And the goal is you can create a centralized secret management system. And instead of providing the exact secrets to your development teams, they can consume them from your secrets provider. And in that case, you do not need to expose your secrets in their terminals, in their system. And you can easily fire them, rotate the secrets from your secrets manager, and everything will be gone. And other development teams and other developer can consume the new secrets. The other use cases is to sync secrets and credentials between different providers. The good thing about the Teller is if you have some secrets from the Azure Key Vault and you want to sync it to and replicate it to, for example, AWS Secrets Manager, Teller can do it without any additional steps. And you can check this drift between your secrets in different providers, and it's safely to consume your secret. You can safely consume your secrets in CI pipelines without exposing them in the environment. You can consume them in your CD pipelines, and you can consume the secrets from different providers at the same time. So I have set up AWS Secrets Manager here, and if we check the secrets value, you can see I have a couple of secrets here, and we want to consume it in my terminal. So instead of providing this value to our development team or to CI/CD pipelines or somewhere else, we can use the teller. So we can call the teller new, and it asks for the project name, and it show you a couple of secrets provider that you can use it in your environment. You can use a couple of them at the same time, but right now I want to use AWS Secrets Manager. And it creates a teller YAML file, which is a configuration, but I already have configuration, configured one. So I can create a teller YAML file, and I can put my configuration, and I provide some values. The stage is dev, and I want to fetch the value from this path from my AWS Secrets Manager. And now if I use the teller show, it provides me some information. Okay, you have the MySQL database, this is the value, MySQL password, and a couple of other secrets. And if I want to, for example, check a command, I can use teller run and, for example, the env command. And as you can see, it injected automatically into this command. And the other thing and the good thing is, in your pipeline or in different environments, I can use something else to show you the drift first, and after that, teller drift, mirror drift, and I can provide the source, AWS Secrets Manager, and target as a .env, and it provides .env. It provides, okay, this secret is available in AWS Secrets Manager, but is not synced with your .env file. That's it.
Ah, here it is.
Another photo finish. I love it. All right. Thank you, Saeed. I'm going to bring everyone back on so we can answer some questions about secrets. Hello, hello. Welcome back. Great job, everyone. You all should feel very proud. I hope you do. Thank you also for clearly putting a lot of effort and intention into your presentations.
To be honest, if somebody would ask me to present something about projects I'm working on in 5 minutes, I would tell them to go to hell. I would not accept those conditions, so I don't know what you guys did and why you did it.
All right. So
I love a challenge.
I think the 5 minutes is valuable so that we get otherwise people are too inclined to dig into the nitty-gritty detail that at this level we just need to be able to compare in a general way what tools do differently from one another.
So when I was putting together this for SOPS, the README on the SOPS GitHub page is so large that it doesn't render, and GitHub tells you have to view the source. So I could have just read that whole thing if you'd have preferred.
That's exactly why we need a user like you to grok that for us lay people, so we can.
Yeah,
get
the thing is when you can. The thing is when you can provide and present it for 5 minutes, you can sell it.
Oh, that too. All right. Let's get down. So our first question's for Anish. If I use CSI driver, can I map secrets from AWS or Azure Key Vault into my cluster? why do I need a more, okay, so maybe it's not for Anish. It's everyone but Anish. Anish is like, hey, this question is more like, hey, I could do this well with CSI driver. Why do I need the more complex solution that you're offering? So let's start with you, Marcus. If I'm already doing this CSI driver solution, why do I need SOPS?
So if you're using the CSI driver, if you want to have somebody be able to create a new secret for you, they need to have access to your AWS account, to KMS, to Azure Key Vault, etc., etc. If you're using something like SOPS, as long as you're not using one of these managed backends, if you're using, for example, age keys like I demoed, you can share the public key just on your GitHub repo in the README, and anybody contributing to that can encrypt a new secret just using that. They don't need access to everything else you've got. So it depends on the use case, right? It's
yet another one of the situations where it makes sense to use these technologies together rather than pit them one against one another like we do. How about is there a use case for?
There's another thing. When you create and making a multi-tenant environment, you probably do not allow the users to create and change the configuration of your CSI driver, because it's at the cluster level and no one can change it. So your tenant inside the cluster should use something else like SOPS or other applications.
Right on. And then is there a use case for using external secrets operator alongside CSI driver?
Yeah, the same.
That's yes. So this is a very good one, because they're kind of competing with each other. So I'm obviously a bit of I'm a bit biased for external secret, but there are a number of differences with regarding to a CSI driver. And mostly those are, for example, our providers are in a single binary, where CSI has like these multiple providers that you need to run separately. And then things like we don't just mount secrets, and we use generators as well. And we have a lot of other features alongside it. And,
my favorite is underutilized push secret capability, because you will be generating stuff in your cluster.
Is push secret? Last I heard, it was alpha. Is it beta now?
No, it's still alpha version, but it is like pretty mature. Most of the many of the providers now do implement it. Some still don't. But yeah, the main functionality is there. It can be used, and I added templating to it recently, so you can now do the templating stuff as well with push secrets.
Cool.
Cool.
And Saeed, instead of asking you how Teller integrates with Secret Store CSI driver specifically, can you talk about how it integrates with Kubernetes more generally?
Yeah. So inside the Kubernetes, instead of using the operators like external secrets or something like these tools, when we want to install our application using Helm charts, we can use Teller to get the secrets from our secrets provider and use the values as an all values YAML file and inject it to Helm command. So it can be consume our secrets and push it to the values to be used in our template, and then generate the final manifest. And in addition to that, in some places that we don't have any specific operator inside the cluster, and we are using some traditional system, not the GitOps model. For example, in Jenkins, GitHub CI, GitHub Action, GitLab CI, and a couple of other CI tools, we can directly call kubectl command. Okay, kubectl create the secret, and use the teller command to consume the secret and push it to the cluster.
Excellent, thank you. Anish, I want to give you a chance to, Gergely got to talk about external secrets operator versus secret store CSI driver. I'd like to give you the same opportunity to say what the differentiators are or how it works well together.
Yeah, I think ESO syncs is Kubernetes secret, right? And we do have that support in CSI driver as well. But CSI driver was actually implemented the first time to like try to move users to use file system, right? Like rather than Kubernetes secret. But there are challenges with it because like if you look at components like ingress and like other Kubernetes specific components, they still heavily rely on Kubernetes secret to exist. So like at this point in time, like what both these communities have been working together. Like what we typically tell users is like if your scenario is more where you have to run like disconnected, so like you don't have access to the vault, then basically you could sync a Kubernetes secret and then access these secrets offline when your cluster is not up and running. And then if you don't have that hard dependency, then obviously you could do secret store CSI driver. And like I said, we do have the sync feature, but we are trying to remove that and make it its own project because we don't think it's the right fit in the driver project today. And I know Victor has talked about it before. I watched this video, so.
And I have two things about the external secrets that I love about the external secrets. The first thing about the external secrets is external secrets supports namespace resources, which means the user with a limited access to the cluster in the some isolated namespace can create the secret store, an external secret, and consume the secrets and push it to the application. And the other thing about external secret is the CSI secret driver mostly can consume and connect to the same RG or same account. But in the case of external secret, you can connect the secret store to some other accounts, other RGs, or any other providers, and then you can consume it within your cluster.
Awesome.
That's right. Yeah.
I want to quickly respond. So CSO, the secret store also supports namespace resources.
Yeah,
so you
newly,
configure. No, actually,
Yeah.
for about 2 years now, I think. So the secret provider class is a namespace resource. So you configure everything within the namespace. And in terms of cross account, we do support it. So like basically you can define which keyword, like which region or anything that you want to access from. And all of that is controlled within the namespace. And the identity is actually tied to the workload. So no identity is tied to the driver. Like the driver has no permissions on its own.
Yeah, but the thing is when you create the CSI configuration, because it's a CSI at the cluster level, other user in the other namespace, they can consume it. And you need to create some policies to reject access or deny the access, I think.
So the secret provider class is per namespace. So like if you cannot define a secret provider class, you cannot access a vault that you don't have access to.
Yeah, it should be, but it's not a CSI.
Let's go to the next one.
Yes.
This is
Yeah.
fun,
Yeah, sure.
but you
Victor.
cannot hit each other and you're not physically present. So
Victor, you've used all of these tools, right?
yeah,
The next
Yeah, I
question's
mean-
for you then.
okay.
What's the best secret management, the best UI for the secret management tools?
I don't use UIs.
The
So-
terminal.
That's the right answer.
Exactly. I mean,
Does a UI
Exactly.
Don't need
have
it.
to mean a GUI? I mean, can any
Okay,
interface
okay.
technically? What's the best one? What's the best
So-
interfacing?
okay, I have the answer. If the question is what is the best one for usage in UI and not browser but any UI, then that's Teller.
Okay. And what's your
Because kind of Teller, I use Teller all the time. I mean, I use others as well, but on my laptop when I work, I need secrets. To do something locally, Teller is great. And graphical user interface. You can type. And you know what? I use Z shell, so it's even having colors.
Yeah.
Okay. Right
Yeah,
on.
fair enough.
And so I have a question from Marcus. How do you ensure your, I believe, files, like your encrypted files, are in a safe place?
With care.
Carefully.
There's nothing built in, if that's what you're asking.
Uh-huh.
Basically, you have to ensure that your processes and your best practices are in place to make sure that you've got Git pre-commit hooks that prevent you from committing in secrets, or you have very good disaster recovery and key rotation in place if you accidentally do have, because at some point we'll leak a secret. It happens, there's no solution to everything. So maybe focus on that end, make sure that's fine. One thing that I've done is ensuring a certain formatting for secret files within my GitOps. So any secrets that are going to be committed in have to be .enc.yaml, for example. And then I have a git ignore that makes sure anything that's not that gets ignored out and doesn't get committed. But it very much depends on like what your workflow looks like and things like that. Unfortunately, there's no just like magic solution that will catch this.
Thank
At least
you.
not that I know of. If anybody has one, please at me. I'll love to know.
Victor, I have another one for you, and y'all are always welcome to chime in and disagree with Victor. I encourage you even. But first of all, do you think there's a use case? Like, would it be a good idea to not use Kubernetes secrets at all? And if it is a good idea, then what's a good way to do it?
I mean, we heard the reason why it's a good idea not to use Kubernetes secrets when we, during 5 minutes of SSCSID. One of those. Okay, the one I cannot pronounce. So there is a strong chance that your etcd is not encrypted, right? That means that your secrets are potentially exposable, right? So yes, Kubernetes secrets are not safe. Let's put it that way. Now, whether they're safe enough for you or no, whether we should go to the length of not using them or no, that would be a different conversation. But the reason would be, hey, Kubernetes secrets are not safe.
Mm-hmm. And so it seems like 3 out of 4 of these solutions avoid using the Kubernetes secret object.
No. Only one avoids using Kubernetes secrets. That's SSCSID.
Okay.
Look at me. Did I say it right? I did.
I mean, you can mount the secrets on external secrets as well.
Oh, you can do it. So you can avoid it as part of external secrets operator too.
Yeah, but we have this notion that once your cluster is compromised, then it doesn't matter.
Secrets are only one of your many problems.
That's why I was trying to avoid to say whether we should do it or no. But if you look for a reason, that's a reason. Whether it's good enough, that's a different conversation, I believe.
Yeah.
Okay.
And eventually you have to store it somewhere, right? And
Yeah.
your cluster, your application running in the cluster will need some way of accessing that. And whether you encrypt that traffic or whether you encrypt that traffic, it doesn't matter at the end. In the end,
my experience tells me that malicious people detect your secrets most of the time because you push them to Git rather than anything else.
correct.
Oh, great. So this is a question for everyone. I urge you to be succinct with your answers because we're running out of time. But we're going to go through and talk about how each tool handles secret rotation, like what happens when secrets need to be updated. So let's start with you, Saeed, please.
So with the teller, you need to probably restart the application because it exposes it as an environment variable. Mostly environment variable, so you need to restart the application. Or you can change your application and add some codes to continuously read the environment variable for the updates.
All right, thank you. Gergely, how do y'all do secret rotation at external secret operator?
I have no idea. I joined too early to the project. I'm not at that point.
I have an idea
Well,
about
you have
that.
the Kubernetes synchronization.
I have an idea about how it works.
Oh,
so,
sorry.
is it the same? Is it the same if you expose and inject the external secrets with an environment variable? So the application need to be restarted. But if you use your secrets as a mounted files, because the mounted files in Kubernetes automatically get refreshed, and there's a reconciler behind the scenes, and then the application mostly can use it.
Yep.
I believe we have some mechanisms for these things in external secret.
Do you have anything
In external secrets, you can set the timer basically to refresh
Yeah.
it every
Yeah.
minute or
Yeah.
hour or something like that. So you don't.
Correct.
And
The
I believe it's
reconciliation.
SSCSID driver as well, right? Kind of like, so you
Yeah.
just
Yeah, both of them can support it.
Mhm.
Yes. And so that leaves you. What does SOPS do in terms of refreshing secrets, updating secrets?
So with SOPs, it would basically depend on when you end up pushing that new encrypted secret to your GitOps or to the cluster or whatever. So if you have a GitOps repo, it maybe Flux picks it up like every 5 minutes or something. And then similar to what Saeed said, it'd update your Kubernetes secret, and then the standard Kubernetes approach. If it's an MVAR, you need to restart. If it's a volume, it'll pick it up. So you can use, things like Reloader to automatically cycle those pods for you if you need to, but there's nothing kind of fancy going on there.
Right on. And then we have a question for Saeed. Why is Teller writing secrets to files or terminal? Why not write it to memory or Linux pipe?
It supports. If you check the cheat sheet, I provided 2 commands with using the pipes that Teller, instead of putting the information on the terminal or the file, you can directly pipe it to your Docker command, kubectl command, a Helm chart, or anything you want.
Excellent. And then should we keep going, Victor? I see I guess we have 2 more questions in the chat. Do you think we have time to finish these
go
out?
for it. Let's
Okay.
go for it.
Any questions from here? We're going to put in the YouTube comments, or please put in the YouTube comments because we're not going to handle them live.
Even better, kind of.
let's-
Any questions beyond those 2, go to the Slack. You choose where you will have to go to vote anyway, and just post them there.
Voting's in YouTube Slack. We haven't put the poll up yet, but we will do that in moments, mere moments away. So let's go through everyone briefly and very quickly say what your integration is like with GitOps. Good, bad, medium. All right. I'm gonna go backwards this time. Marcus, what's your integration with GitOps? How's SOPS?
Very good. So Flux has built-in support for SOPS. Argo CD has support via a plugin called KSOPS, which is basically what's used with Kustomize. Not sure about solutions beyond that, but if you're able to run Kustomize, you're then able to use the KSOPS Kustomize plugin. So it should integrate quite nicely like that. It's seamless. You kind of just commit in your encrypted secret, and as it's applying it to your cluster, it decrypts it for you into a secret.
Amazing. Anish, tell us about...
I've heard about few integrations, but I don't think I'm completely aware of how well it's been integrated in the GitOps world.
All right.
But do we, sorry for interrupting, but for the SSCSID and external secrets, right? There is no integration really. Those are Kubernetes resources.
Because they have the synchronization loop in Kubernetes. Yes.
Yeah, the resource is there. When you create your manifest, it works. Yeah.
That's the beauty of the loop. Yes.
But your actual secrets would then be managed outside of GitOps, right? Because you still need to create them in the vault or whatever that you're installing them in.
Yeah, that's a very good point. Mm-hmm.
Yes.
All right, and Saeed, how does Teller work with GitOps?
Okay, so in Argo CD, there is a solution called CMP, Custom Management Plugin, that you can add a custom management plugin into Argo CD repo server, and by using this functionality in Argo CD, you can put your Teller into repo server that when it tries to generate the manifest, doesn't matter from the Helm chart, customize the raw manifest, it can use Teller to push the inject to your manifest and then apply it to Kubernetes side. So it can be easily integrated with Argo CD.
Okay, so I think this last question is exactly what you just said. Let me just confirm. You're saying that
I didn't go before.
Oh, I'm sorry. We
was
just
messed up.
spoke for Kubernetes. Okay. Yes.
Yes. So external secrets is very good with both Flux CD or Argo CD, whatever. It's end-to-end tested nicely, and at the end of the day, it's just YAML. So yeah, you can put it anywhere you want.
Awesome. My apologies, Gary. And then, did you just say we can inject values from the provider into a values file using Teller? That's correct?
Yes.
Yes. Yep. Excellent.
It's not just about the secrets. You can push some configuration, the entire values YAML.
Excellent. Cool. That's a wrap for the Q&A session. We're going to say goodbye to everyone. You get to say a closing statement briefly. We're going to say goodbye in the order we presented. So, Marcus, what's your closing? Wait, Victor wants to say something. What's up?
No, I want to reiterate that briefly, Said.
Very briefly. We're
So we've got another 5 minutes,
Saeed.
right?
Victor's timing. Don't make him do it.
Yeah.
He wants to. Marcus, 10 seconds.
Cool. So the reason I like SOPS is it doesn't rely on any external services or operators to be running. Fits really nicely into your GitOps and just kind of works nicely. Seamlessly.
Awesome. Thank you so much. Have a great day. Bye, Marcus.
Right?
And Anish. Actually,
Okay.
let's go in the order.
Yeah.
Yeah.
You said
Gergely.
Danish.
But I also said Gergely at this point. Gergely, let's hear your closing statement, please.
All right. So external secrets is very good with GitOps, and you can integrate it anywhere, use with any provider, and the community freaking loves it, and so do we.
Awesome. Bye, Gergely.
Bye.
All right, Anish.
Okay. Treacherous CSI driver. It's a Kubernetes SIGOT sub-project. It has a familiar file system mount experience, pluggable external secret providers. So we've had like a lot of companies implement their own providers, supports rotation, and also pod portability across Kubernetes environments.
Impressive. Thank you, Anish.
Thank you.
And Saeed, last but not least.
Yeah, never leave your terminal with secrets and vote for Teller. Thank you.
That was very fast. Great. Good job. Wonderful. Here we are. We did it. What a fantastic show. Now we
Yeah.
have one very, very important thing to talk about.
The vote.
What is that?
The vote.
The
The vote.
votes.
I should find it somewhere. I have a
I
link.
just- I
There.
just made the I just made the poll live. And so head on over to the YouTube channel on the CNCF Slack. Let's put this as a link in the chat too. Do you have it handy to do that?
Yeah. I am. If I find, yes. The
Okay.
important thing is, I think, I need to remove it from the
so you
screen
just
and then
click a-
copy it. Anyways, it's in the description of the video. That's the important part, right? So
It's in the description of the
I'll
video.
put it in the chat, but the important part is it's in the description. Go there down. It's below. Click it. Vote it. Vote for it. Vote for any you want.
Yes, but just one. And then whichever
Are
one
you allowed to vote for two?
No.
Okay, so there is no need to say about the restriction.
He asked me, but he didn't believe until he tried to press the
I
button.
did.
That's all right. You're a tinkerer. I get it. So that's it. The poll is live for 3 days. Whichever technology you choose will be the one we implement in the next episode's demo, but it's also going to be the one we use for the whole rest of every show we ever have ever again.
Exactly.
Yeah.
When
it's a big
secrets
decision.
are used, so not in every show. Let's make it clear.
Yeah. But as you saw, like when Argo CD was chosen, therefore we're talking about it a lot. When YTT got chosen for application configuration, we've spent a lot
Exactly.
of time with YTT because you chose YTT. But that's a wrap. Victor, do you have anything else to say?
That's it. That's a wrap.
Come join us next week. We're going to talk about network policy and MTLS.
Yes,
Yes.
with unknown number of projects.
5, I think. All right.
Since one of us is following. Excellent.
Goodbye. Thank you for your time and attention today.
Bye-bye.